All right, good morning, everyone. Hope you are doing well. Hope you had a wonderful weekend as well. It was cold and kind of wet today, but hopefully it's going well for you, okay? Today we're doing lesson 316, create a table and graph for linear and quadratic equations. So that's our goal today, okay? For today, you will need graph paper, okay? All we're doing is on graph paper, so you do need a full sheet of graph paper. Please always make sure you have graph paper. If you do not have graph paper, you can also see about printing some offline, but our work today is fully on graph paper, okay? And then a pencil. We're going to do problems 53, 54, and 55. Your homework is the review preview for this lesson. So it's just 55 through 60. So that's the review preview. That's what you need to do for today, okay? Actually, let me verify. 56 through 60. My bad. 56, not 55. So 56 through 60 is what you're going to do right after this video here, okay? So it doesn't give me the little thing to switch with. It always does this, and I can't believe it. Okay, and I haven't learned better so far, so here we go. What makes a complete graph? That is the goal for today, complete graphs. Over the past several days, you have learned to make graphs from tables, then graphs from rules. Today, you will continue your study of graphs by deciding what needs to go into a graph to make it complete. First of all, we do need to answer some questions here. So please type in or please write on your paper. Again, you wrote down 3.1.6 nice and big on the top of your graph paper. Please put problem 354A. And then please take about 20 seconds. It should take you about 20 seconds. And tell me what are the coordinates of point A. Okay, coordinates of point A. And go ahead and answer that. Just tell me the coordinates. That's all I need you to do, okay? All right. If you need more time, pause it. Otherwise, I'm continuing. For B, please tell me where will the line be when x equals 5? Okay? So tell me what's going to happen when x equals 5. Where will the line be when x equals 5? Again, if you need more time, please pause it. And you're just writing down these answers, and I'm going to go back and go over them. And last but not least, what is t when k is 1? What is t when k is 1? If you need more time, pause it, and then we'll continue. Got it? All right, so here we go. Let's backtrack here and answer the first question. What are the coordinates of point A? Point A. And if you went there, maybe you saw this line here, so, and then you saw this right here. So a lot of you put 2, 1. And that would be wrong. You're like, why was it wrong? Well, ladies and gentlemen, if you haven't figured out from the activity we're doing, maybe you got a little frustrated. You should have, because what we're addressing today are some common mistakes that people make. Right here, something is wrong. Why is this not necessarily 0.21? Because I don't have a scale. You have to tell me a scale. Now, if you said, hey, this right here is 1, and this is 2, and this is -1, and -2, and -3, and then this is 1, or -1, and -2, and this is 1, and this is 2, then this would be 0.21. But this also could have been 2, 4, or 3, 6, or whatever. This could have been 10, 20. And so since we don't have a scale, we have no way of knowing for sure. So, maybe on that one right. Need a scale, okay? So as you might assume, there are some errors with every single one of these. Anyone catch what the error is here? It says when x equals 5. Well, the graph does go to x equals 5, but the line doesn't. And should it? Well, we don't necessarily have the arrows here. And the arrows imply that you continue. If you don't have the arrows, technically it stops there. So technically, there was no value when x equals 5 because it stopped right here when x equals 4. So according to this graph, there would be no x equals 5 because there were no arrows. If you wanted to continue, you have to put arrows. So needed arrows. And last but not least here, what is t when k equals 1? And I know when you first saw this, you were like, Mr. Ramirez, what on earth are you doing? You are crazy. I don't understand this. And the problem is, or the thing is, we could, if I would have said, hey, this is t and this is k, I could have answered this. Or if I could have said, hey, This is K over here. It doesn't have to be X and Y, and this is T. Whoa, that's an ugly T. But you could have, had I said this, well then 1K is 1, then this would have been, but it doesn't necessarily even tell me the scale there. But one of the key things I need to do is I need to label the axes. That's not x's, axes, okay? The x and y axes. So all of 3 of these problems dealt with some common misconceptions and common errors on graphs, okay? So that was kind of the fun, kind of catchy thing here, okay? Next problem, problem 54. Is this 54 or is this 55? I think it's problem 55. For problem 55, what we're going to be doing now is we're going to be making some graphs, okay? There we go. Problem 53, man, I'm all over the place here, okay? So, actually, my bad. Will you do me a favor? Will you go back to that first problem over here? That should have been 53. 52. That first problem should have been problem 52. So the one we just did, the one with the errors was problem 52. This is problem 53, okay? So problem 53, what we're going to do is we're going to make a complete graph for each of the following roles, okay? So this is where you needed your graph paper for. And on your paper, if you could please write this equation, y equals -1 plus x, okay? Now, before you make your graph, I should not have put that graph on there because it's going to throw some things off. But I always start with the table, x and y. And if you remember, I asked you to go from -3 to +3. Now, if you wanted to go a little further, if you wanted to go to -4 to +4, that is perfectly okay, all right? But I wanted to check, and that's the basics, -3 to +3. That's enough for me at that point. I'm good with that, okay? So will you do me a favor? If you think you know how to figure out this table, go ahead and do it. So pause. If you think you know how to fill out this table from -3 to +3. If you don't, just go ahead and stick with me here and we'll go over it right now, okay? All right. So this right here is the key problem here. That's what's going to mess people up right there. This refers to the opposite of x. So if x is -3, what is the opposite of x? It would have been +3. Plus 1 would be 4. Now this equation is basic enough, it's small enough that you do not need to show all your work for this process. If you want to, you can. If you need to, you can, but you don't have to. I'm not going to require it of you because this one is a simple one or a simpler one than we're used to or than we'll see a lot of. So you could probably do a lot of this in your head. Okay, so now it's the opposite of -2. The opposite of -2 is 2, plus 1 would be 3. The opposite of 1, -1 would be 1, plus 1 would be 2. The opposite of 0, well, the opposite of 0 is just 0, plus 1 would be 1. What is the opposite of 1? If this was 1, the opposite of 1 would be -1, plus 1 would be 0. By the way, by now, have you noticed a pattern here? Do you notice all these, what's happening to those? Let's verify. The opposite of 2 would be -2, plus 1 would be -1. And so then we can assume that this would be -2. So I need what quadrants? I need all 4 quadrants. So that's where you see I have this. Now, at home, you do not need to make a graph this big. I just have this as my set graph because this is what I've got here for my work. But to make my graph work, whatever graph you make, it does need to be appropriate space. So I'm going to have to make every square worth half. Okay? And I'm going to go to 4. Right? And then over here, I do the same thing. Do you see how I'm putting my lines on the line? So -1, -2, -3, -4. Please make sure that when you make the graph, you don't do this. Don't put it on the spaces, okay? Or don't do this either. Don't just put, oh, well, this is -1 and -2. You gotta put lines, and they've gotta be right on the line, okay? Always when you do this, on the line, -1, on the line, -2, on the line, -3, on the line, -4. Now, even though my graph just goes from my table goes from -3 to +3, I'm going to go ahead and go on to 4 and -4. That's okay. And then as you notice on the other side, it goes all the way from 4 to -2. For me, because of my graph, I'm going to keep my scale okay? 5. Then -1, -2, -3, -4. I could have also not written all the numbers. I could have done this. I could have just, I'm going to erase, I know. I could have just done this, put my lines here, and then here, put -5. You can do that and put just the final number on there, all right? Now, I'm going to graph my points, plot my points. So -3 is +4, -2 is +3, -1 is +2, -0 is 1. I should have gone in a different color, my bad. There we go. 1 is 0, 2 is -1, and 3 is -2. I then, since this is an equation, I'm going to go ahead, and it's not a word problem, I'm going to connect the dots. Now, do you remember what I call when I connect the dots? Do you? This is called continuous. Continuous when I connect the dots. Okay? And there's my graph. Now, here's the thing. Oh, how many problems do I have? I think I just got one problem. What did I do wrong, or what am I missing here? Hopefully you caught it. Hopefully you didn't do it. What I'm missing is my x and y. X and y. Cool. All right, there's my graph. Hopefully you got it right. Did you? Okay. Well, hopefully you did it with me, so that should be no problem. The next one, you are going to do this one on your own now. So again, I want you to make a table from -3 to +3. You can go sideways like that or up and down. X and Y, -3, -2, -1, 0, 1, 2, 3. Okay. So before you make it, just when you're done, make the table and try to fill it out. When you're done, unpause it. I'll just give you the answers right here, and you can check it, okay? All right. And then after that, make your graph. Okay. So here we go. When you do this, it's 2, it's 2.5, this is 3, 3.5, and then this is 1.5, 1, and 0.5. Okay, so that is what we got right now. Those are the values you should have gotten, okay? Please go ahead and write those values down. Now, will you please make an appropriate graph for that? When you got it, unpause it and compare it. Okay, here's what your graph should look like for this problem. Now, first of all, what quadrants do I need? Technically, I only need 2 quadrants, quadrant 1 and 2. Now, look at what they did here. This is the book's answer key. They went ahead and went a little farther. So they included all 4 quadrants because they went to -5. And by going to -5, you do eventually get to the numbers, the negative numbers here. So if you didn't, you could have just done quadrants 1 and 2 and had your points from like here to here, and that would have worked perfectly well. You should have arrows, you should have X, you should have Y, you should have a scale. You should have arrows and arrows and arrows. Did you? Okay, good. Now one more we're going to do, okay? And this is the bulk of the time that we got here, okay? So stick with me here. This is almost done with your class time here, okay? The last problem we're going to do is a little bit trickier here, okay? And it's that, x squared minus 4, x squared minus 4. Now again, I'm going to go ahead and do one of them with you here. So I'm going to make my table here, x and y, -3, -2, -1, 0, 1, 2, 3. You should be doing this with me. Now we're going to plug some values in and actually try to figure it out. What is -3 squared? Now, here's the thing. Be careful here. When I plug this in, this should be -3 in parentheses squared minus 4. Okay, so answer that. And then when you're done, look, see if you agree. Get it? Write that down. See if you get it. What would the answer be if x is -3? What would y be? All right, well, let's see. Right here, this right here, -3 in parentheses means -3 times -3, which is +9. Minus 4 would be 5. So when x is -3, y is 5. Okay? So I want you to pause now and finish the table. When you're done, Unpause it and we'll compare our values here. Okay, so you should have this table filled out. Please tell me you did it because that helps so much with just making sure that you understand. So if x is -2 squared is 4, minus 4 is 0. When x is -1, -1 squared is +1, minus 4 would be -3. Then 0 squared is 0, minus 4 would be -4. 1 squared is 1, minus 4 would be -3. 2 squared is 4, minus 4 would be 0. And 3 squared is 9, minus 4, which is 5. And it looks eerily familiar. Look at that, look at that. Boop, boop. Okay? So make your graph. When you are done with your graph, please unpause and see if you got it right. All right, here we go. Here's what your graph should look like. Ooh, and do you remember what the name of this thing called? This is called a, what's that name of it? It's called a parabola. Parabola, okay? All right, the very last thing I want, so good job. Hopefully that graph makes sense, okay? Now, technically, we're doing problem 54 as well. 54 just says go back and identify what we call the x and y intercepts. Now, you probably have heard of y-intercepts before, but this time they're introducing the x-intercepts as well. And so we're going to go back to this first problem right here. I'm going to identify the x and y intercepts, and then you're going to work on the other ones. This right here is my y-intercept. Okay, and I'm just going to summarize it like that. Actually, for this first time, I'm going to write it out. Y-intercept. And the coordinates of the y-intercept are, and it's always a coordinate point, 0, 1. Okay? This over here is called the, I'm going to go with black this time. This is called the x-intercept. The coordinates of the x-intercept are 1, 0. Cool? All right. So please now identify your x and y intercepts, write them as a coordinate point for all of these. On this one, like in the future, you don't always have to write the actual words x-intercepts and y-intercept. You can just go ahead and say, hey, excuse me, this is 0, 2. Now on this graph, you didn't necessarily go to the y-intercepts, the x-intercept. So you might not have this one, but the x-intercept we can say here is -4, 0. And this is the y-intercept. And we can just summarize it like that. Cool. Last but not least, this right here, x and y-intercept. Ooh, now this one, this is the y-intercept. And the coordinates of that are -4, 0. But this one has 2 x-intercepts. This intercept here, which is 2, 0. And this x-intercept here, which is -2, 0. Cool. All right. Okay. Well, ladies and gentlemen, one last thing we need to talk about. This is the last thing, okay? And this is just you writing it down. For complete graphs, when I tell you to make a complete graph from this point on, here is what you must include. You have to have these several things, okay? So please write this down. Most of them are pretty straightforward and obvious, but we just make sure we get them all. Number 1, you must have a title. Now, if your graph is just an equation, like the practice problems we did here, you have 2 options. On an equation, you do not necessarily need a title. That is okay. If you do not put a title on there, I'm okay. However, if you choose to put a title in, you can just write in the equation. Okay, so that's an option, is to just write the equation for it. Okay, so either a title or an equation, or none if it's just a simple problem out of an equation. If it's a word problem, though, it must have a title. Number 2, write it down. Write this down, and preferably if you can write it in red pen, that'd be even better, or highlight this. The x and y axes need to be labeled. It's pretty straightforward. Number 3, number or correct scale. You have to have numbers on it. You can never just say, well, it's just 1. Now, a lot of my graphs that I've given you they don't always have a scale because it's open for you to enter it in, okay? Number 4, arrows. Arrows at the end of the x and y axes So like right here, arrows, 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 but also on your graph if it continues, okay? Number 5, you must identify if it's continuous or discrete. Now, please remember, continuous does not mean that it goes on forever. Continuous means it continues between the points. So continuous means I connect the lines because I can find the values in between. Discrete would just be dots. Okay? So you got to be able to figure out if it's continuous or discrete. You can't just assume. Number 6, you got to plot your points, of course. That makes sense. Now, you got to have the points figured out. And number 7, you have to have labels. Now, again, it depends. If it's a word problem, you just have your, if it's just a basic equation, X and Y is perfectly good. But if we were talking about how many hot dogs you eat and how long it takes you, we'd have to have our labels of time and hot dogs. Cool? So these 7 things you must have included in your graphs always and forever from now on it, okay? So always think through this list. Always make sure you've got all these parts included. All right. Then, ladies and gentlemen, your task now is just to do the review preview. So our review preview for this lesson starts on problem 56, 57, 58, 59, and 60. So 55 through 60 are your review, or 56 through 60 are your review preview problems, all right? Thank you. Sorry for being a little late on today's video. Hopefully you had other stuff to do and now you can work on your math, all right? Turn this in, please, by midnight tonight. Have this done by midnight tonight because tomorrow we start the next lesson. So you got to get this done today, all right? Thank you. Bye.